Hey everyone, today I wanted to make a video as a thank you for getting 100 subscribers on this YouTube channel. Thank you for watching my content and subscribing to the channel. I hope that this gives you another reason to keep on subscribing and watching. So today I'm going to be talking about Android mobile application penetration testing, and specifically we're going to be looking at an application called Injured Android, which is used for capture the flag activities and can be used to, enhance your skills in terms of Android penetration testing. So once again, I just want to say thank you very much for subscribing, and I hope you enjoy this video. So what we're going to be talking about is getting started with Android penetration testing, going to kind of show you some tools and everything that you're going to need to know to get started in Android app pen testing. Then I'll tell you a little bit about Android, how to pull APKs from an Android emulator. So, for example, if you're doing a bug bounty hunt or something like that, or you want to go out and investigate any publicly available applications out there, I'll show you exactly how to pull that APK out of the Android emulator and to look at it. And finally, we'll do the live demo of Injured Android and go through a couple of the flags that are stored on there. So to get started in Android penetration testing, what you're going to need is definitely Android Studio. How you obtain Android Studio is, you can just look in Google for Android Studio, and you can see here it's just very easy to download for any of your devices, Windows, Mac, etc. Android Studio is actually a very useful tool. Let me pull it up here. You can have a variety of emulators, which is basically a Android phone that is on your computer. It's emulated, and as you can see here, if we go to the AVD manager, it's not opening. Oh, here it is. You can have a variety of different devices, and you can see here, if you look for the ones with the Play Store icon, those will come with the Play Store automatically installed on that phone. Other useful things about Android Studio is that you can actually see the device file system here. So this is my Pixel 3, and it's running on Android 10. You can see here, you can look down through the entire file system. You also have a terminal here where you can execute commands like adb shell, which drops into a, a Unix shell on the Android phone, and you can also exit that. And there's also obviously tons of tools for developing in Android Studio. It's primarily a developer tool, but it's also very useful for penetration testing in terms of getting a variety of emulators and having emulators with the Google Play Store already installed if you're looking at trying to get publicly available apps. So going back to our slides here, the next tool that you're going to want to know is X Gui. And there's a variety of tools that can do the exact same thing that X Gui can do. Basically, it's a decompilation tool. It allows you to decompile the APKs, which is the applications that are stored on your Android phone, and it allows you to pretty much browse through that and look at the actual source code. This tool is available on GitHub, so if we just look for X Gui, it's the first result here, Skylot JADX, and you can install this for your system however you want to. And you're going to need Java first as a requirement, but this tool is very useful. You can actually just import an entire APK in there. There's many other tools to do very similar things to JADX, but I find that this tool is the easiest and the most user-friendly for me. The next tool is Objection, and this is actually a Python library, and there's going to be two things you need to install with Objection. One is Frida, and basically what Frida is, it's a runtime tool that injects code into an Android application, and then you're able to manipulate the Android application in certain ways. So, for example, you could try to skip to areas that you were not previously able to access. You could try to dump memory addresses out of the program. You could try to check the Android keychain for certain stored secrets. And Frida can also allow you to bypass SSL pinning. So you can install both those tools by doing pip install Objection or pip install Frida. Keep in mind that you need to install Frida before Objection, and this tool is very, very useful if you're using a publicly available application because SSL pinning is usually implemented. And basically, what SSL pinning does is it is an extra verification step of security certificates between the device and the endpoint. So it's basically verifying that the certificate is valid and no one is man in the middle intercepting that traffic. Another thing that you should probably have before you get into Android pen testing is just some experience with Java. You can get some good lessons off of Free Code Academy. Um, most apps are written in Kotlin these days, which is kind of a variant, but you definitely want to know some Java just so that you're able to read code. You don't necessarily need to know how to code to do Android pen testing, but you do need to know enough to be able to read and understand exactly what it's saying. In terms of automated reporting, another great tool that I really like to use is called MobSF. And basically what this is it's kind of an automated pen testing platform. Again, it's available here on GitHub. And basically you can use this for iOS applications and Android applications. And what I use MobSF for, it will give you like a security score, it will tell you permissions, all kinds of different stuff like that about the application. But what I use MobSF for is it's kind of like a shortcut for me. So I'll look at the MobSF report and pull out some interesting details and then go look at those manually. But you can also use MobSF to do a variety of other things. And one of the cool things about MobSF, especially if you're a bug bounty hunter, is that you can actually do a differential report. So, for example, you can take an application version that was made, say, 3-4 months ago, and compare it to the newest version that the developer released today. So, if you know that they're putting out some new features, or you know that they're maybe making some changes to their backend system, or you know that the application has gone through a lot of changes recently, you can actually compare the two versions, and maybe that will help you to understand how the attack surface of the application has changed over time. So this is a very helpful tool that helps to automate the process a bit, and it helps to basically point out things that you can go look at manually and help to speed along the process. Another great course, definitely on Udemy. I've recommended this one in other videos before. This hacking and pen testing Android applications. There's also an iOS version. Keep in mind, if you're going to be doing iOS pen testing, you're going to definitely need a Mac computer, and most likely you are definitely going to need a actual iPhone to do that penetration testing. So if you're looking for something that's a little bit more platform independent, definitely look into Android application pen testing first. This course is really great and it will teach you a lot of things about how to use Frida, how to use Objection, and a few other tools that I won't be covering too much in depth in this training. So this is definitely a course that's worth investing in. And of course, if you're looking for a formal certification, I can highly recommend the eLearnSecurity Mobile Application Penetration Tester certification. That certification is a 7-day exam, and you will be pen testing an Android application as part of that. They do not do iOS applications because of the issue with the you need to have a Mac and you need to have an iPhone. So uh, the test for the eLearnSecurity mobile application pen tester is all Android based. So let's talk a little bit about injured Android. Again, you can find this on Google, and it's a GitHub project, and it's right here. And the cool thing about this is that this actually has all the answers in here. So if you get through this video and you're confused about something that happened, or you want to see maybe like the additional ones that I'm not going to be going through, you can easily go in and find all the walkthroughs right here. You can see it's right here, Injured Android Flag Walkthroughs. And it tells you how to set up everything. And the cool thing about Injured Android is that it's actually available on the Play Store. So I'll go to my Android emulator here, and I was already looking for this, but you can just look up Injured Android, and it's a little bit far down this list, but right here it is. And you can just install that on your device. And here, let me open it for you. So basically, the app has a few different flags, 17 different flags here, and each one kind of has its very own um, exploit that you're going to be using. So for example, flag 7, SQLite, that's probably a hint of where you're going to find the flag. Flag 8, AWS, Firebase. And what I really find valuable about this injured Android app is that it actually has some really common bug bounties that you could find in applications. Like AWS is used by a lot of companies. Firebase is definitely used by a lot of applications that are out there. So this definitely has some modern exploits that you're going to need to use, and it's definitely a good proving ground if you want to test your ability to do Android pen testing. Okay, so to get started here, all we need to do is pull the APK off of the emulator, and then we can play with it on our local machine. So how we can do that is that we can open the shell here in Android Studio. Let me clear my screen. And to get into the actual emulator, you can do ADB shell, and that will drop you into a shell. And if I do a list of the file system here, you can see that we are in the Android file system. Now, how we can list our packages is that you can just do pm list packages, and this will list all of the packages on the phone. As you can see, there's a lot here. That's all of the applications installed on the phone. So to make this a little bit simpler, we can do a pipe, if you know anything about piping commands for Linux, and do a grep for just the word injured. So basically here, we're just searching for the word injured within this list of packages. You can see here the package name is bnac, injured Android, so we're just going to copy that. And now we're going to use the command pm path and then paste the name of our package. Oh, it didn't like to copy there for a second. And here, this is listing the actual path, so you can see it's under data, app, bnac, injured Android, and this is the actual APK name. So we can actually exit our terminal now once we copy this path. Copy, do exit, and now we can use the command adb pull. This will pull the package off of the Android device, paste our file location, and then we can name it anything that we want. And I am going to call this injured.apk, just so I know what it is. Okay, now I'll be right back, and I'm going to pull this file up in JetX. Okay, so now I have the application open in X Gui. And as you can see, this tool kind of separates the application out into three separate parts. You have your source code, your resources, and your APK signature. Don't really worry about the APK signature for right now. It's not really important in this case. But this would be used to validate that the application was signed by whoever it's supposed to be signed by, and it ensures that, the application is legitimately signed. The resources area contains important things like the Androidmanifest Xml, which defines a lot of areas about the application. It also contains a lot of UI elements, different boxes, and different definitions for how things actually look in the application. And it also contains resources, which is things like the strings that are used in the application, certain things that might be stored. As you can see here, there's like assets here. There is Kotlin, some libraries that are imported. As you can see, these libraries are also differentiated between the architecture of the actual device this is installed in. And here we have our Androidmanifest.xml. As Android pen testers, we definitely want to take a look at this because the Android manifest is kind of really where the application is defined from a starting perspective. So you can see here, there's a min SDK version and a target SDK version. That basically defines what devices this application is able to be run on. So it goes all the way back to min SDK version 21. And so we might be able to use a emulator from a previous version of Android, which could allow us to root the device and maybe do things that are malicious to the application or that you otherwise would not be able to do. When you're pen testing, you definitely want to look to get this min SDK as high as you possibly can. Usually we look for something around like 23, 24, 25 for the min SDK for more modern applications, and definitely anything under 21, and especially anything like 17 or 19, those have specific vulnerabilities associated with them. So if you're looking at a publicly available application or you're developing one, um, sometimes you can run into some issues there with the version that is being supported. As developers, we always want to try to include the largest customer base possible, and obviously if you set the min SDK to 1, then you're including pretty much every Android device that's ever been made. But obviously there's some security implications with doing so. Here, the permissions of the app are also defined. And permissions is basically when you install an application, it usually asks, for permission to access your camera, permission to access maybe the storage of your device, and sometimes, maybe even permission to the microphone or other areas of the phone. So in this case, the application has access to read and write external storage, has access to the internet, has access to network state. It's really not that bad from a permissions perspective. There's some other permissions out there in terms of Android that could be much more easily exploited, or could be suspicious also in terms of the application possibly containing malware. So that's something you definitely want to look at when you're looking at any kind of Android app using a tool like JADX. Now going on here, if you look at this, kind of like this BNAC injured Android, this is called an activity. And basically all the activities are, it's just UI elements, different screens that you can navigate to within an application. And there's certain things here called like intent filters, and also just intents in general. Sometimes, if you think about this from an application perspective, maybe there's an area where you want to log in to first before you're able to get to that screen. Well, if you do not protect your activities properly, you might be able to jump around to different activities that otherwise you should not be allowed to access. So you always need to be careful, especially when you see this like activity exported equals true. That could potentially be used to access this activity by going around a login screen or possibly accessing it from another application. So sometimes you can write a proof of concept application that takes advantage of these kind of things. Anyway, let's take a look at the actual application now running on my Android phone. And you can see it's very simple. And we're going to just do 4 flags out of here that are going to be really easy to go through and explain to you all. First, we're going to start with flag 1, login. Okay, and you can see here at the top, this is labeled flag 1, login activity. And you might be wondering now, like, where is this UI actually defined within the code? Well, it's actually up here in the source code section. And you see all these different libraries, but the one that you really had to worry about is the one that actually applies to your application. Sometimes when you're looking at a big application made by a company, you'll see a lot of different libraries and things like that in here that's referencing source code from other areas. But in this case, we're just going to be worried about the BNAC injured Android. And we're going to go down here to the flag 1 login activity. And flag 1 is right here, flag 1 login activity. And here you can actually see the actual source code for this application. And basically, what's kind of cool about this is that you can see here snack bar. Now, a snack bar is basically a little UI element that pops up from the bottom of the screen and it says some kind of a text. So here, this says snack bar X, and it's going to have this text. So if we actually do this in the application, you see exactly where this action kind of lines up. And if we press the help button again, it says the flag is also under the GUI. And you can see here that this is actually defined in the source code right here. And if we keep on scrolling down here, we take this hint seriously. They say the flag is also under the GUI. Keep on going. Down here we see this if statement. So it's checking to see this edit text. What edit text means is that there's a text box. So where do we think that there's a text box where we can edit the text? Well, of course it's right here, so we can actually input the flag, right? And it's checking to see if edit text.getText to string, so it's converting our input to a string, and that seems to be comparing it to this flag 1. Okay, so if we type that in, f1ag underscore 0 and 3, oops, submit, you can see that we found the flag. And basically, all that is right there is just a hard-coded string. We're comparing one string of input to another string of input. And you might think that this is a very basic example and you'll never see that in an actual application. That's definitely not true. You can see this sometimes in a lot of different applications. If you take the mobile application penetration tester course, you will definitely see this kind of thing in there. And basically, think about this from like a username or password perspective. Somebody could hard code a special username, or admin password in here that would be checking against, or potentially sometimes like a coupon code if you're thinking about shopping apps. Maybe there's like a hard coded testing coupon within the application itself that you could actually utilize to maybe get a special discount. So this is definitely something that you want to take a good look at, and check for these kind of hard-coded strings to see if they could be used in any way maliciously against the application. Okay, so we solved that one. For the next one, we're going to go to flag 3 resources, just because I know this one is pretty easy. And if we go to flag 3 activity, we can see it's very similar in terms of the source code to flag 1 activity. You can see here the snack bar, it says R stands for resources. Of course, R stands for resources pops up when we click. And when we click our second time, we see it says check.xml files. Now, if we scroll down again, this one's very similar to flag 1. You can see our if statement here says if edit text.getText.toString, so it's converting our input to a string. And now it's checking against this thing called r.string, cmv, zb, blah, blah, blah. And we can actually take this and try to look for it using JADX Magic Wand tool if we'd like. This would be one thing that you could do. Try to find all instances of where this string name is being used. And also another big hint here is this one where it says check.xml files and it says R stands for resources. So if we get nothing out of the magic wand here, you can see it's kind of defined here in r.string, but where do we think that these resources are actually stored? And if you think back to where we started before, this is actually under the resources, resources.arsc, and this is where a lot of resources are stored. You see all these different values. Most of these values, it's just about different types of dimensions that you have on the screen. So if you have a watch, have this running on a watch or a smaller screen, it changes the dimensions of what's on the screen. And you see all these values, -be, -ar, that is just things that are in different languages here. So you can see that this one right here, this is all in Arabic, right? So our application can be applied in different languages. So in this case, the only one we really need to be concerned about is this top values here. You can see a lot of XML files are defined here. And this is usually true of a lot of applications, okay? And usually I will take a look at this XML. Sometimes you can find some things in there. And definitely the strings.xml is one area that you want to check in every mobile application. If you're doing a bug bounty, you might find some juicy bounties in here. It's always a great area to check. Even right here at the very top, we can see there's an AWS ID, AWS secret key. These can be used in a further exploit, okay? This could be potentially access to an S3 bucket, an AWS S3 bucket. And if we scroll down a bit more, oh hey, this thing looks familiar. The CMV, ZB, blah, 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 right? We saw this exact same string defined in the flag 3 activity. And it looks like the flag should be this F1AG3HR33. F1AG underscore THR33. See if that works, and we can see it works. But now what was the logic behind that? Like, what did the developer do that was different than the previous time? Well, in the flag1 activity, they defined the string right here within the actual uh, class itself. It's actually, defining the hard coding the string right into this class. In this instance of flag3 activity, the developer kind of tried to get tricky and tried to put the string inside of the resources so that would be a little bit harder to find, but you can tell we still found it pretty easily. If you're still looking through the strings.xml, you can still find those kinds of references, right? So let's go down a little bit more through this strings.xml, and you can see that there's all kinds of different stuff in here. A lot of these things are little kind of like variable names, has a lot of strings, and this is kind of like the text that will be used throughout the entire application. You see like flag 9, flag 10, the names, the titles of these activities. And something you definitely want to look at when you're looking at the strings.xml is things like API keys. Maybe they have something called secret_key, or maybe they have a Google Maps key that you might be able to utilize. So this is definitely something to check. And another thing that you want to check is definitely for anything related to Firebase. And Firebase is basically used as a logging mechanism for a lot of applications. So right here we see Firebase database URL. This is where a lot of things could be stored from the application. Maybe it's sending logs to a Firebase database. Maybe it's sending sensitive information. And this is something that you definitely want to check when you are doing a penetration test. And there's actually a flag related to this one. Go down here, flag 9 is Firebase. So it says input the flag, push submit, use the .json trick with database URL. So a lot of times with Firebase, something that you can do to check to see if it's secured properly is that you can just paste it into a web browser, do a slash and a .json. And sometimes you will get a result here, but if it's secured properly at this level, then you see this permission denied error. So that didn't work right away. But is there maybe something else that we can look for that would give us a hint? So let's actually go to the source code for this one. And this was flag 9, so flag 9 Firebase activity. We see here this string is defined ZMXHZ3MV. And we scroll down a little bit more. It says something about encoding. So maybe that flag is, or maybe the string is being used in some way. If we scroll down a bit more, you can see here there's a base64.decode and it's using this string. You could also have seen this as a reference to whatever variable was being defined before. But if we decode this string now, as it says to do in the source code, we can actually use something like CyberChef and just put the string in here. And let's see what happens when we translate this from base64. Oh, it goes to flags. So looking at the source code a bit more, that is called the decoded directory. So it's been taken through this decode function, and it's called the decoded directory. So what if you just use that as the directory before the the .json? So flag, it's flags, flags /.json. And here you go. This would be the flag. So even when we find a Firebase instance like that, it's not always enough to just check for this .json. This is kind of the lesson from this one. As you can see, this is like permission denied, right? You want to make sure in any Firebase activities like that, that you're looking for any additional directories that they might be getting to. That might lead you down a path where you're able to actually extract some data out of those Firebase activities. Okay, so that was activity number 3. And we'll go back here to flag 8 AWS. And the hints here, if we go into the actual activity, flag 8 login activity, says AWS profiles and credentials. And I'm going to leave this one up as a homework assignment for you. And something that you can do, which we already saw, is look in the strings.xml for these AWS ID and secret keys. And you can actually utilize these to log in to AWS and get access to the next flag. And to give you some hints on how you're going to do that, you're going to need this tool called AWS CLI. And basically, you're going to download that tool, and then you set up your profile with those access tokens that we found, the AWS secret key and ID, and then you can try to get access to the storage bucket. And where the storage bucket is stored is actually still in the strings.xml usually. Somewhere in here, if you look deep enough, you will find the storage bucket target for this activity. So I hope that homework entices you to take a look and to use these strings to try to access that AWS bucket and get the flag. And I hope that this overview of Injured Android inspired you a bit to get into Android pen testing. And if you have any questions, you want to know more, um, in terms of the actual Injured Android application, there are walkthroughs published on the GitHub page. And if you get stuck, just feel free to go take a look and learn about all the flags and how you would get to them. And if you have any questions on mobile app pen testing, I'll be happy to answer them in the comments. Thanks for watching, and thank you again for subscribing and getting us to 100 subs.